I am Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today we are going to discuss different type of problems and test of hypothesis for single proportions problems, similarly difference of proportions problems. Before going to discuss single proportion or difference of proportions, as we have discussed in the previous sessions, what is sample proportion? Sample proportion means it is a P, the number of exhaustive events by the total number of events. If you take the number of exhaustive events are X and the total number of events are N, then proportion which is denoted by small p. Simple example, if a manufacturing company out of 200 goods, 18 were defective. In this case, what is sample proportion? 18 by 200. That means it is a proportion of defective. Sometimes in a manufacturing company, out of 200 goods, 18 were good goods. In that case also, P equal to 18 by 200. Either it may be good or bad, we can take a total exhaustive events, which is denoted by X, by the total number of events. That is called sample proportion. Similarly, the population proportion we can denote it by capital P, which is 0.5. Exact divide we can take P equal to 0.5. Now, in test of hypothesis for single mean proportion, suppose a large sample of size n is taken from the population, and sample proportion is small p and population proportion is capital P. Then the test statistic Z equal to small p means sample proportion minus capital P population proportion by under root of PQ by N. Here you know that small p is sample proportion and capital P is population proportion. And we don't know the value of capital Q. We can calculate by using the formula Q equal to 1 minus P. The confidence interval for single mean, like that here also we have confidence interval for single proportion P. That is P plus or minus 3 into under root of PQ by N. Small p plus or minus 3 into under root of PQ by N. Suppose if I take one problem, we'll see experience has shown that 20% of manufacturing are top quality. This is the general statement. Experience had shown that 20% of manufacturer are top quality. In 1 day's production of 400 articles, total number of articles are 400, N equal to 400. Only 50 are top quality. The exhaustive events are 50. Therefore, X equal to 50. Then sample proportion is 50 by 400 by using the formula X by N, which is 0.125. What we are going to test the hypothesis of top quality at 0.05 level of significance. Small p you know that, N you know that, X also we got it. And capital P generally we can take 0.5, but in this statement given that for every 20% of manufacturer top quality, he mentioned that point, general mention point, that is capital P equal to 0.2. That means capital Q equal to 0.8 because P plus Q equal to 1. Now, which test we are going to use? If you observe the sample size is large, that means test of hypothesis for large samples. Here we are not going to verify the single mean because mean value is not given. We are going to test that proportion because in 1 day's production of 400 articles, only 50 are top quality. According to this statement, we decide that this problem is suitable for test of hypothesis for single proportion. Now we are going to set null hypothesis by taking capital P, population proportion 0.2. And alternative hypothesis which is against to null hypothesis, alpha value 0.05, Z alpha value we can choose from the table. And in step 4, the test statistic Z equal to small p minus capital P by under root of PQ by N. Small p value we got it 0.125 minus capital P 0.2 by under root of 0.2 into 0.8 by 400. So which is minus 3.75. You can take mod Z 3.75 and Z alpha value we got it 1.96 and mod Z equal to 3.7. According to this, mod Z value greater than Z alpha. That means we reject null hypothesis. We reject null hypothesis means P equal to 0.2 is a null hypothesis. We are rejecting P not equal to 0.2. That means whatever the statement he passed, 20% of manufacturer are good quality, it is a wrong statement. We can conclude that it is a wrong statement. Coming to second problem on test of hypothesis for single proportion, in a sample of 1000 people in Karnataka, total number of people in a Karnataka are 1000. Out of 1000, 540 people are rice eaters. See, according to the sample proportion, you can find out rice eaters is 540 by 1000. The sample proportion P equal to 540 by 1000. The rest are wheat eaters. Can we assume that both rice and wheat are equally popular in this state at 1% level of significance? So P equal to 0.5, Q equal to 0.5. Alpha is also given 0.01. So Z alpha is 2.58. So what is the Z formula? Small p minus capital P by under root of PQ by N. If you substitute all these values, here we are going to get Z is 2.532. Mod Z also 2.532. Mod Z is less than Z alpha. That's why we accept null hypothesis. Coming to the next test, test of hypothesis for difference of proportions. Instead of test of hypothesis for single proportion, here we are going to take difference of proportions. Only the change is here we have two samples instead of one sample. Two samples with sizes N1, N2 and their proportions. Sample proportion is denoted by small p, but two proportions are there, P1, P2. These two samples we can take from the population proportion capital P. Then the test statistic Z equal to P1 minus P2 by under root of PQ into 1 by N1 plus 1 by N2. From this we know all the values except P and Q. But we can find out P value. P is N1 P1 plus N2 P2 by N1 plus N2. After getting P, we can find out PQ equal to 1 minus P. Suppose, if you take one problem on test of hypothesis for difference of proportions, in a sample of 500 people in Tamil Nadu, 280 are tea drinkers and rest are coffee drinkers. In a sample of Tamil Nadu, so N1 equal to 500. 280 are tea drinkers. 280 are tea drinkers and rest are remaining 220 are coffee drinkers. And N1, N2 equal to 500. Both are came from same population. Can we assume that both coffee and tea equally popular in this state at 1% level of significance? So we can find out P1 value x1 by N1, P2 value x2 by N2. Here N1 and N2 we have taken same sample, two different samples as 500 only. Now you can set up the null hypothesis P1 equal to P2, alternative hypothesis which is against to null hypothesis. And alpha is 1%. That means Z alpha is 2.58, not 1.96. So test statistic Z formula P1 minus P2 by under root of PQ into 1 by N1 plus N2. But we don't know small p value. We should find out small p value by using the formula N1 P1 plus N2 P2 by N1 plus N2. N1 P1 value 280 plus N2 P2 value 220 by 1000. We'll get small p 0.5, capital small q also 0.5. Now you substitute in the formula, simplify it, we'll get mod z equal to 3.79. But z alpha is 2.58. Mod z equal to 3 point something. So mod z greater than z alpha. So we reject null hypothesis. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.